Hey guys, just want to do a sound check. Jace, then can you do the sound check for me?
Hello, can you hear me?
Okay. So, yeah, when you're ready, just tell me. I'll start the call.
Okay, PR, let's start.
Sure. Okay. So, hi everyone. You are in a community call from OpenGuild streaming live to you guys right now. And this biweekly talk is brought to you by OpenGuild collaborating with Polkadot Insider. If you are a tech savvy or a big fan of Polkadot ecosystem, OpenGuild is the community for you to join. So we have technical sessions, we throw series talking about Polkadot as well as Web3 world. So yeah, let's embrace our community and share it with your tech friends. This week, we will lay our hands on ink. So, as many of us may have known, ink is a programming language designed specifically for writing smart contracts on Polkadot network. So, our talk today is going to be quite technical. So that's why I got Tin, our developer relations engineer at OpenGuild, here with us to introduce ink and underlying the architecture of ink. Tin, how are you doing?
Far so good.
Okay,
Be
so
better.
yeah,
From Malaysia blockchain. Yeah.
oh, you just got back from Malaysia, right? How was Malaysia?
Yeah, we like our workshop in Malaysia is quite crowded. Like we got like 30 people joining the workshop.
Oh, great. So, it was like just one workshop, or was there like many workshops there?
Can you say again, Pia?
Oh, yeah, just asking about the workshop. Did you guys like make like different workshops or only one?
So we make two workshops straight because
Mm-hmm.
it was given like 3 hours of like in Malaysia blockchain week like to present about Polkadot. I just like host two workshop about Polkadot, about like getting started with Polkadot SDK, so like introduce about like the tech of the Polkadot.
Mm-hmm. So how do you think about, throwing workshops like that, like overseas like that, uh, expanding, our community. How do you feel?
Yeah, I think it's quite rare. Like I met a few like Malaysian developers who interested in the Polkadot technology. Like met some student, usually like some like usually like event like Malaysia Blockchain Week. had a lot of student, and on the other hand, like the OpenGuild team, Chris and I like, also like connect with a few other like developer community. So like hope that we can like collaborate with them in the future to host a few hackathon and also like in Malaysia as well.
Yeah, I do reckon that OpenGuild is going to do even more workshops within this year. So yeah, keep us all the news. Yeah, let's go back to our sessions today. Well, like we said, today is about ink. So just a warm up question. So I know that you're gonna talk about ink at any minute, but so you don't have to go too details. But can you share with us your general thoughts on ink? Maybe in a dev perspective, do you think like it's a challenging language to you to learn?
Yeah, I think like um as a software engineer, like I already like experienced with a few different programming language, and in terms of like smart contract language, like my very first language is Solidity. Um,
Mm-hmm.
I think like the great thing is about ink, like ink exactly it's just basically Rust. So like if you learn Rust, you simply like, just already know about ink. So like for any like and especially like developers who build on Polkadot, or I can say like Subtrade developer already like experience with Rust programming language. So in on that way, like when they try to build the application on Polkadot, like building a smart contract, then like it doesn't like have too many like obstacle for them because like now they already passed the learning curve of Rust programming language. So now they just have like learn a few different features of ink and they just apply on building the project. Yeah.
I see. So it's a very interesting topic today. So I'll leave it to you. Let's get right into the sessions today. Tin, I'll leave it to you.
Okay, yeah, thank you, Bia. All right, so let's get started. And thank you, everyone. Thank you, everyone, for joining our community call today. About our workshop today, like Bia already introduced, so we're gonna talk about ink. Not too deep, but I'm gonna like try to make my try my best to cover like all the things that I know about ink and also like a basic understanding about ink. If you don't know about this language yet, so to introduce a bit about myself, so my name is Tin Chung, and I'm the OpenGuild Developer Relation Lead. On the other hand, I'm also a Polkadot Blockchain Academy Wave 5 graduate in Singapore cohort, and I also like class myself as a Polkadot SDK contributor, and as currently I'm sort of working as a software engineer. Okay, so for anyone like who don't know about like OpenGuild yet, or if this is your first experience with OpenGuild, so OpenGuild is the Web3 hub for like Polkadot enthusiasts in Southeast Asia region. So like if yeah, you want to learn about Polkadot, and learn about like building on blockchain, then this community is for you. Like this a great way for you to contribute to the Polkadot ecosystem. For the past activities of OpenGuild lab, we already like develop a lot of courses, not only like in Substrate, but also like in Rust. For example, like we have like Open Rust, also like we host a few like OpenGuild monthly hackathon and a few online offline workshop. So that like developers and also like other builders, Web3 enthusiasts can join our workshop and connect with each other. So here's like some images that I can showcase here, so that you can see like how have we done in the past few months across like the Southeast Asia countries. For example, here like we have Sub-Zero in Thailand, where like our team come there to connect with like uh, other parachain team across the globe, and also like we have a few other events in Malaysia, like the Korean party that like Chris and I just like joined the past few days ago. We also like have offline workshop in Vietnam and also like in Philippines. So about open contribution bounty, this is not new, but like for anyone like who don't um okay, so before like I continue, so I think like yeah, I passed the man. I think like you're you define yourself, so like just check and yeah, like if you need any help, like our team can help you if you related to like technical issue. So about the open contribution bounty, this is not news. It's already introduced to you guys, community member, a few weeks ago. But it's still running. And for about the open contribution bounty, I think this is a great way for like any developers, any builders, any like content writer who interested in Polkadot can like join and sort of like write and join our track and then contribute to the Polkadot ecosystem. Other than like we also like want to bring like the learn to earn program to open contribution bounty. The price pool for this open contribution bounty gonna be up to like $20,000. Detail about it, the open contribution bounty. So we have like 5 different track. For example, you have like the track one substrate course, which like anyone like who wants to learn about substrate, they gonna can build a very basic substrate. We have like a list of topic, like 20 topic right now, and then you just like visit like openguild.wtf, and then like all the list, check some of the topic in the list, and then like find like any kind of topic that you're interested into, and like you contribute to it, write documentation, then you claim the bounty. On the other hand, like, we also like have ecosystem open source documentation. So like if you're interested in like writing the documentation for Polkadot SDK or like writing documentation on Polkadot Wiki, so this track is for you, and the price pool for it is like 4,500. And we also like have technical blog, and then I think like our community already like very interested in this track, and then like we already generate like 3 to 4 different blogs written by the community. In the Jack 4, we're gonna have like workshop technical activities, and even we have a Zinzi right here, who is also like the winner of this bounty track. And then like he already like built a repository called like OpenHackDot that like to help you to learn about um like connecting with the substrate blockchain to a client library Condidot. And yeah, so if you're interested in like building something like a tutorial project, then yeah, you can show check for. Then if you have any other idea, OpenGuild community also like open for you to like submit the proposal to us, and also like contribute like on top of your proposal, and then you can claim the bounty, the check file. Okay, so to to congratulate on our recent winner, also like related to Ink. So Leo Fam, like yeah, he's like a very close member of the OpenGuild community, and he already like claimed for the track 3 technical blog that he wrote an article about Ink. And yeah, congratulations. Okay, so about our agenda today, we're gonna like introduce a bit about Ink and advantages of Ink, architecture of Ink, building application with Ink, and reward Ink example. So basically, we cover like everything that you need to know about Ink. So what is Ink? So Ink is a smart contract developed by Parity, and this is a domain-specific language built on top of Rust for the Polkadot ecosystem, which is like 100% compatible with the Parachain environment. So Ink is a gateway for application built on top of the Parachain. We're gonna deep dive into like how Ink gonna be can be built and can be added as the extra functionality for your Parachain. And on the other hand, like Parachain only needs to add the pallet-contract to support Ink. Also like discover about pallet-contract later. So let's take a look at like the very most popular smart contract that like blockchain application currently have, which is Solidity. And I think like everyone here is already like familiar with Solidity. You at least like at least once if you in the blockchain space. So Solidity is more like a domain specific language. However, like Ink doesn't, even though like I mentioned it as a DSL as well. But in fact, it's not a domain specific language, but Solidity is more like a domain specific language. So what is a domain specific language? So a domain specific language is a language that is designed for a specific use case in computer system. And in this case, Solidity is designed for like for the smart contract development on Ethereum. So let's take a look at the workflow of Solidity so that we can understand Ink in a better way. So let's say you have a smart contract written in Solidity here, and then you're gonna go to a Solidity compiler, compile into like contract API, then like you submit it as a bytecode. It will be compiled as into a contract bytecode, submit it into the EVM, and then later gonna update the state blockchain. That's how Solidity works. Now we go back to Ink. So Ink is built on top of Rust. So if you're already familiar with Rust, basically you already know Ink. So Rust plus with the macro, which is like a meta programming feature of Rust, you're gonna like generate the new language called Ink. So some key features of Ink be introduced at inherent safety guarantees with the Rust programming language. We know that like Rust is safe, right? Like security of Rust is inevitable. That like everyone like who already researched about Rust definitely know that. And that's also like the reason why you're gonna choose Rust over other system language like C or C++. The other hand, like the ability to use the normal Rust tooling. So like Rust tooling like Clippy, Rust format, Grad.io, IDE of Rust, like VS Code or Z, like Rust Rover. You can still like use all those things in the developer tool. So like tool in the Rust ecosystem um, for Ink because Ink is basically Rust interoperability with Solidity contract. So it has the ability to like cross contract code with like the Solidity contract developed on like the Ethereum compatibility layer. And it have a clear migration path for graduating to a parachange. It can be a gateway for any new security developer who join the ecosystem to like kickstart their blockchain first with the contract to test the functionality, and then later they can like upgrade from Ink to like a very like complete and mature parachange. Ink is compiled into a WebAssembly. On that way, like it's also like established in industry standard for the compiler target. Native to Polkadot, complement your substrate parachine perfectly. Okay, so I gonna mention a little bit about like some component in ecosystem. First is about a pallet-contract. So the pallet-contract is the module that you're gonna add to your runtime if you want to turn your substrate-based blockchain into an like compatible blockchain. So if you want like to give your substrate-based blockchain the ability to like execute the in contract, then you need like this pallet-contract. For anyone like who don't know about a pallet, so pallet is basically a library, or like you can say it as a module in a which is like in a more correct way. Then like you're gonna add this all these kind of palette into your blockchain to add the functionality to your runtime. Palette is the gateway for the substrate developer to define the new logic for your runtime. So palette contract is the contract module provides functionality for the runtime to deploy and execute WebAssembly smart contract. If you look at the illustration right here, so the in smart contract or Solidity smart contract or even like assembly script, the Polkadot ecosystem going to be compiled into the WebAssembly bytecode, which is the platform agnostic language, and all those type thing will be sent back to the runtime. And the pallet-contract mentioned that it's gonna be like the waiter who gonna like receive the bytecode and then handle all the kind of things like execution, calculating the gas fee, and then like store it into the storage, and also like update the state of your blockchain. Next is about the cargo contract. Cargo contract is the next component when you develop the Ink application. So cargo contract is the command line interface tool which help you to like set up and manage WebAssembly smart contract written with Ink. Here, like you can see like cargo, you can install the cargo contract. Then installation step. I can send the resource later to like OpenGuild Discord. But basically, after you install, you're gonna have like a command like cargo contract. With this cargo contract, you're gonna have a few other sub command like new view. For example, like new, you're gonna set up and create a new smart contract project. which is like set up a new ink smart contract. Build, you're gonna like build your smart contract. Check, check like that the code build as a web simply does not output any like artifact kind of things. And test, test smart contract like very simple and like straightforward. Upload, you're gonna upload the contract code. The upload one gonna be used in case of like you want to like upgrade your contract without like instantiate your contract again. This is also like an advanced feature of Ink that allow you to like update the contract to the new version. About the workflow of Ink, so the Ink contract is written in the Rust EDSL, then Ink will be sent to will be like compiled view by the cargo contract COI, compile the contract Rust code to the WebAssembly and generate the metadata information for it. After that, you're gonna have like first of all a hello world dot contract file, and the dot contract file contain the WebAssembly blob and metadata for the contract. The WebAssembly blob is uploaded to the blob to the change. Then the contract palette will handle this WebAssembly blob. And the WebAssembly blob target a stable API exposed by a substrate contract module. Module for smart contract uh, provides function to execute contract, asset a contract storage, etc. And the contract palette will be on the substrate runtime side. However, like the cargo contract is just like a separate tool that you're gonna use to like compile ink into a doc contract file. Imagine this is also like similar to the flow of Solidity. So like you have a Solidity contract and you're gonna use tool like Solsi so that you can compile it into like the API of Solidity in Solidity, and then like that Solidity will be like submitted in like to the EVM to the Ethereum virtual machine, it in the form of the bytecode, this like the special bytecode of the EVM ecosystem, and like it will be like executed by the Ethereum blockchain. So in like in Ink, like Ink is advanced because like Ink can be applied into like different use cases. First, we're gonna be like in smart contract as a first class citizen. So the most obvious use case is a pair change which provides smart contract as a first class citizens, meaning smart contract are the central value proposition of the change. Um, and this is like a very common use case of smart contract in any blockchain. You can like take an example, for example, like Ethereum, also like have the contract as a first class citizen. In the Polkadot ecosystem, we have a few other blockchains that also like apply Ink as a first class citizen, which has like Ink as a base unit for any developer who want to be the application on this blockchain have to use Ink. First gonna be the Aleph Zero, the second one would be the Aster, and the final one would be the Fala. So we're gonna talk a little bit about the architecture of Ink. First, it would be like the data type and storage. So ink is very simple, and as we mentioned, that like ink is basically Rust. You can see here like um you define when you define a new ink contract, when you define a new like in storage, you just need basically a struct in Rust and also the data type. Here's all the data type in Rust. For example, like you say 32. And on the other hand, like Ink also like offer some advanced data structure, which is introduced in the Ink like version 5.0 or something. And these special data structure are gonna be like string or vector that you can like add into your like contract. Getting value in contract, which is quite simple. Then this is also like an immutable reference of an immutable reference of the struct, and then like, you just simply like code a few of the struct similar to Rust. On the other hand, like you also like have like mutating like the value in the in contract. Let's say like if you want to update the value of the if you want to update one field in the in contract, then you just basically do something like self dot my number equal to the new value. But in like it has the immutable and mutable variable. And to allow that, then you also like have to add the mutable you have to add the mutable before self, which is also like it's just basically like a Rust thing, not the ink thing. Event emitting in ink. So this also introduced in the version 5.0 of ink as well. So like when you like emit the new event, it's gonna be like sent back to the runtime, and the runtime gonna handle the event from the contract execution, and then also like emit that from like the runtime as well. So event emitting in ink and how does it look like? So you're gonna like define a new event in ink with like the macro ink event. For example, here like transfer, to transfer from from like owner to the destination with the value. Um, and then like to like emit this event, then you just like simply call like self environment like emit event transfer from owner to the destination value. Yeah. Very simple. Like if you code in Sub.j, it's also like something like this. But like if you code in Solidity, it's also like exactly something like this. Yeah, one thing that I forgot to mention is about macro. So you can see here, like even though it look like Rust, but like the the special thing that you have to add into your like Rust code to turn it into an to add that into your Rust code to turn that into the in contract is like all these kind of macro. Similar to like when you like develop the palette, you also like have like palette storage, palette event, palette error, or like palette core. So like in the Polkadot ecosystem, like every development gonna be driven by the macro. And that's also the reason why like all these kind of meta programming features gonna like the in smart contract can build on top of Rust, but can also like provide more feature that we're gonna mention in the later slide. Selector. Um, so when like your contract is compiled, then like you can use a selector to like point directly at, for example, like the functions, also like the functions of the trade. For example, and the way it's work is like the name of the function. For example, you have the functions called like Fobinate, and then like it's gonna be go to one like hashing go to like one hashing functions using like the black 2 algorithm, and then like, you're gonna take like the 4 bytes, the first 4 bytes, the hash string, and then like by that way you're gonna got like the selector hash string of the functions with the trade. Then it's also similar to that, but in that way like, you're gonna have like the trace. The trade will be like the first component of the preimage string, and on that way like, you have like the function name here. Then like you also like go to the hashing algorithm, which is run like the black 2 hashing algorithm, and then like you got also like take the first 4 bytes, um then you got like the function selector string of that function in the trade. So about the trade definition, so trade definition, I think it's already like a very popular feature of Rust. So we don't have to introduce it again. So basically, it's just provide like a set of interface that like when or whatever struct implement this interface have to implement all these kind of feature similar to like interface in order like OOP programming language. So in here like on my left hand side is the as I remember like on my left hand side here is the trade of the ERC20 of the ERC20 API. So like when you develop on Ethereum, when you want to add like the ERC20 to your like application, then like you have to use the ERC20 API. And it's gonna provide like, a set of method like name, symbol, decimal, total supply or balance of. And in case you also have the trade. Here is like a very simple trade collect based ERC20, so it doesn't have all the functionality like allowance or like transfer form, but it's have a very like basic method like total supply and transfer. But as you see, like the Solidity like API one and also like the trade the base ERC20 trade in case is also like looks quite similar. And more advanced concept in ink is about gas. So for every operations on the contract side of the ink, the gas got to be matter by like the pallet contract under the hood. I also like have a blog post right here for anyone like who interested. Um, let me see. Anyone who interested to read more about like gas metering in case of ink. Like different from like runtime development. In runtime development, like we have the concept called a weight, right? And like in weight, like you like the developer, the substrate developer, have to calculate the weight by themselves. But like in case of the contract, like the gas is matter by the pallet contract, define the runtime, and the gauge is calculated using the ref time and also the roof size. So the ref time is the amount of computational time that can be used for execution in picoseconds. And the roof size is the amount of storage in byte that a transaction is allowed to read. But in the case of like a solo blockchain, like Alab Zero, which is not a parachain, so like the roof size is not used, but only the ref size. Um, because like the roof size is explained here is only like relevant for the parachain Polkadot or Kusama network. And on a high level, like roof size is the size of the roof that individual parachain send to the Polkadot or Kusama relation to allow re-executing their block for validations. So in like when like you submit when the parachain submit a new block to the relation, it's gonna go to one inclusion pipeline, and it's going to generate a validity roof called like roof of validity or POV. And this is like this roof size is basically an attribute to like to identify the size of that POV. But yeah, in the case of solo chain, like because it's not a parachain, so it doesn't have any concept of the relation. So it's only use roof time to like, calculate the final gas for any operations on the contract. So contract upgrade, similar to the subtrade runtime upgrade, contract code can be upgraded using dispatchable function called like upload code without instantiating the contract again. So basically, when you compile, like when you compile using like cargo contract, um, the ink smart contract will be compiled into the WebAssembly, and then using like a dispatchable function called like upload code, you can like overwrite the code of that WebAssembly block in the runtime, and in that way the contract can be upgraded without like you have to instantiate the contract again. Yeah, so you can read here is like some dispatchable function that already like capture on the pallet contract. For example, like instantiate um let's see, like upload code and remove code. So when we already learned about upload code, that is upload a new code without instantiating a contract from it. But like for remove code, so it's gonna remove the stored code and refund the deposit to its owner and only allow to the code owner. And I also like have a pallet contract deep dive. So if you're interested, then you can read more about it. I'm gonna send a picture here. Anyone who interested. But I think like from like the in smart contract developer, you don't have to care about all these captains because it's quite low level. So in the full stack in development, you can use Inkaton, and then when you use Inkaton, it's like a React app as like COI, and then like you when you run like no sorry, so it's basically a boilerplate, a repository that you can find on GitHub, and then when you install, this gonna like contain all these kind of component that you can use and like to kickstart develop on Ink easily. And the component of the using Katon that you can start on GitHub, but it's basically a monorepo structure that's contain like the front end and the contract side. So for the front end, it's like use Next.js, and then like the client library is going to be the Polkadot.js. But I think like the Polkadot.js is already like quite deprecated and is no longer uh like suitable for new like modern application built on top of Polkadot. Then like you can like consider using like client libraries like ddot or like Polkadot API. Yeah. And on the contract side, gonna like prepare for you like this template for the contract, and also like it's provide a substrate node which already repair with a pallet contract. You can sort the keyword called like substrate contract node, which is like a template node that already have a pallet contract like installed on on your substrate based blockchain. Compare Solidity with ink, then we have like a virtual machine. Then ink is compatible with any kind of WebAssembly virtual machine. For example, like in the Cosmos case, uh, like Polkadot definitely, and what else? Um, let's say like if like all the people like running like build a new blockchain that have like the WebAssembly as like the execution as the like the bytecode executor, then like definitely ink can also like be used in that case. But in Solidity case, it's only like compatible with like Ethereum virtual machine. And like if you don't use Ethereum virtual machine, then like you cannot use Solidity. That is all like limited things in Solidity case. In encoding, then ink is encoded into WebAssembly. But in Solidity, it's encoded into EVM bytecode. Language gonna be Rust. Solidity is just basically a standalone language. But Ink is like built on top, and it's just basically Rust. That's all the reason why the Rust developers really love Ink. Um, also other feature like overflow protection, which is like quite deep. And then you can learn more about it when you develop in Ink. Um, Yeah, so in tooling, so Solidity have to develop their own like developer ecosystem to support like building to support building when try to build the smart contract in Solidity. But like in case it can just reduce the Rust toolings to like because it's basically Rust. Anyway, like all the thing is not major, so we can skip it. Um, Another use case that I really like in Ink is in smart contract as a second class citizen. So we already like mentioned Ink that can be like the first class citizens, and the smart contract as a first class citizen is a very popular use case that like most of the blockchain developer are gonna know. But like as a second class citizen, this concept is new and is only like apply can only like apply in the Polkadot case at this moment. So what is second class citizen? So there is another not so obvious use case for pallet contract. The smart contract as a second class citizen on an existing change. That is like we mean that like essential value role position of the change has nothing to do with smart contract, but still include them as an add-on. Doesn't mean we can just like take a real world example, which is a pop network. So like pop network, like they're basically a network that allow you to like pay gas fee in dot, and also like allow you like to call the runtime API call the runtime API, call the dispatchable function, which is um like any logic defined in the runtime side directly in ink. So like in that way, like for example here, like can develop an you can develop an application that can stack to the protocol of Polkadot from the inside. So the way the pop do it is like they make use of one advanced feature of ink called chain extension, which is like basically extending the change, and the chain that we mentioned right here is basically the runtime. um Yeah, so let's say that the runtime is have functionality like asset, NFT, governance, identity, DeFi. Then all those things can like be called and also like executed from the smart contract side. So some ecosystem news for anyone like want to update. So Ing is now maintained by the community. Ing in the first place was innovated by Parity Technology, which is also like a core company behind the Polkadot protocol. But now like Ing is already transferred back to the community, and there's three entities right now are responsible for like maintaining and developing new features Inc., which is our lab zero, CEO Labs, and also like Roche is also like the company behind Pop Network that I just mentioned. About Ink V5, so recently there's the new release of Ink that we can like learn it together. So like in the Ink V5, interesting thing is like Ink collaborate with Open Zeppelin to like generate the security report, and I think that this one is very like thoroughly written. So like if anyone like want to learn about like the security side of Ink, then like feel free to read this report. Um, so actually like core runtime and core chain extension, you can imagine that is basically the same, because like when you see like the illustration right here, you're gonna see like just communicate with the API palette, but like the difference is like the core chain extension, um Gen extension gonna have the customize they like the pub network, they gonna have like the customized code in the runtime that only they support in the pub case. That's the reason why we call it Gen extension. But like on the core runtime case, it just like use like the default functionality of Ink to code directly to the runtime. um I think like this illustration is like quite deprecated, because like they released this report a few months ago already, but now like the design of pop network already like changed a bit. But I think like simply speaking, just imagine that like um Ink gonna like send one call to the API in the special API library of POP called like the POP API, and then that POP API um gonna like encode the byte, and then like send back to the runtime to the Gen extension, and from Gen extension the runtime have to implement the things called like Gen extension API, which is a trait in the subtree runtime. Then like this Gen extension API gonna accept that bytecode, and then like they have to parse that bytecode um somehow in the old way, and also like to like use a method for like dispatch call to dispatch API it defined in the palette. Yeah, I hope that is explained to you. I don't think that this current time make any like difference, but like right now like it's just like called Gen extension. I think yeah, that's is a similar case. We go back to Ink V5, and then let's see like what kind of features that we have. Okay, so yeah, let's go back to this security. So like if you're interested, like just read like the whole security, because we don't have time for this work in this workshop. If you use Gen extension, there is need to be the same on your runtime. Um, I might not like understand this question. But yeah, it would be best if you can describe it more. But let me show you. So Gen extension. So this is the inside, right? Inside extension contract. So on the inside, so when you like implement the chain extension, you have to implement it on both sides. first it's gonna be like on the inside, which like have to implement like the chain extension here, and then like you like dispatch the call, and then like it's call like go back to the runtime. On the runtime side, you also like have to implement another. I did not like I did not expect that there gonna be like too many questions related to the chain extension, but like mm, so like when you um when you develop your own customized chain extension that you want to like expand the functionality of Ink to connect with the runtime, then you have to call this trait, and you implement this trait to your runtime. Basically, no, like you implement this trait to another struct, and then you just like provide the struct to the config of the palette contract. Then it can provide the chain extension. So in the chain extension, it's gonna have the main method called the core, which is also like the endpoint. That like when you like call the chain, when you like dispatch the chain extension from inside, it's gonna be like sent back to this core method. But like in this core method, when you receive, all the environment gonna be in the in the by value, which is like the vector of the usi of usi a integer. So yeah, and then so like you have to like write your own parser to like handle that case. But like that one is quite deep. But basically, like the flow gonna be like the ink also like have to implement their own like chain extension trait, and then like it's gonna like also have to implement their own call, and then like dispatch, and then like send back to the runtime, which also like have to implement their own chain extension, create the connection between the inside and also like the contract side. So like the ink can send like the data back to the chain extension. So and receive the chain extension, like it's only like everything is the bytes. It don't have the ability to like execute the method in the method in the runtime side yet, but you have to use um you have to like implement your own and then you can like use a method called like dispatch call um on the runtime side, because now you're on the runtime, right? So like you can call dispatch call to execute the method of the palette. Yeah, something like that, something like that. I remember like everything you receive in the by value. It's not like you can call the method directly. So like in pub case, like if they want to call them, if they want to call the method in the runtime, they have to receive like a set of bytes. And then in pub case, they also like some special bytes, like in front of the vector. For example, like uh, a version of the runtime, a palette index, also like a method index. Even like in the error case, they also like require error index. So like all those three information will be added in front of the byte array you receive, and then like in the chain extension call method, they're gonna like pairs those bytes back into like the dispatch call of the palette. So like in that way you can like dispatch then you can call the method on the runtime. So let's go back to the ink go back to the ink v5. Um, in V5, they have a new feature called like testing with chain snapshot. Um, yeah, and this one is used like Akala chopstick. Basically, they simulate a whole blockchain network from the chain spec. So like you provide the chain spec generated from the substrate side to the this chopstick, and it's gonna like help like simulate a chain snapshot from like the data that they receive from the chain spec. And in that way, like ink can like be run for like end-to-end test using like all these chain snapshot. Yeah. There's another library called Drink App Zero. Um, yeah, I haven't used this yet, but as I remember, if we visit the ink doc, we can already define Drink in the testing and debugging section. So this Drink, as I see here, let's discover it together. Um, I think that it's also like for end-to-end testing, like Drink maintain a full in-memory blockchain state and allow you to interact with it directly. This give a notably robust methodology in contrast to the option engine. Um, uh, bu- 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 yeah, so as I understand, like, so basically, let's try to like do end-to-end testing in like on the production environment. Yeah, and a new data structure called a story fact or a vector that we just like visit. Like if you remember something like in prelude vector. So like this is a new special vector added to ink that like try to like replicate the functionality of the vector in Rust, because like ink is also like on the web, like on the WebAssembly environment, and in the WebAssembly environment it is non-standard. And what is non-standard? So like in non-standard, like you cannot use the functionality of the OS or like relies on the functionality like the IO, because like those things are like biased on only like designed for that's I think that's not a right word to say, but like all those kind of things. So for example, like OS API or like IO is only like um designed on the standard environment, which is like your device or something, but on top of like the WebAssembly environment that like you have to do non-standard. In event, which is like we just mentioned, is also like introduced in the V5. And but like to use the in V5, you have to upgrade your cargo contract to the version 4. Okay, so I think like yeah, that's like some of the most popular the keynote of like the in V5. And there's some real world application built on top of ink as well. For example, like in the case of Aleph Zero, they build a decentralized domain the decentralized domain management using ink. Like for example here, like I create a new domain ID called like OpenGuild.Aleph0. And under the hood, this one is ink. And ink is also as I remember, you can also like use like Inkscape, which is developed by one of our then yeah, I don't think that I can find Inkscape here, but yeah, it's developed by Cincy, which you can find in the group chat. Um, and for example, like some on a lab zero, there's also an NFT marketplace built using ink as well. So yeah, yeah. So Cincy like send me Inkscape. This application is quite cool because like quite fit to like community like OpenGuild, because it's allow you to like create like multiple community on this social ink application. And here like you just sign in. No idea why he only like support wallet. Yeah, anyway, so like in this application you can also like explore, for example, like these are like community hosted on like Aleph Zero testnet. And yeah, like if you like want to like try the performance and also like how smooth is the application can be, then like feel free to visit the link that Senzi just send to the group chat. And yeah, and I think that that's all for the community call today. Yeah, thank you for like watching, and also um join the community call hosted by OpenGuild community. And then I hope that we can see you in the next week community call. I gonna send back make to like here.
Okay. Thank you, Ken, for being very specific in all the Q&A. And yeah, I think we had a very insightful sessions on about ink today, and Tin have covered from what ink is all about, its unique traits, the architecture, and of course its benefits and possibility. So I hope you guys find it helpful. It's been great listening to your speak today, Tin, and I can't wait to your next session. So yeah, this is the end of our community call. Have a great weekend, you guys, and we will see you very soon in our next call.
Thank you, everyone, and have a good day.
Thank you, everyone.